Mars is the fourth planet from the Sun and the second smallest planet in the Solar System, larger only than Mercury. In the English language, Mars is named for the Roman god of war. Mars is a terrestrial planet with a thin atmosphere and has a crust primarily composed of elements similar to Earth's crust, as well as a core made of iron and nickel. Mars has surface features such as impact craters, valleys, dunes, and polar ice caps. Mars has two small, irregularly shaped moons, Phobos and Deimos. Mars is approximately half the diameter of Earth, with a surface area only slightly less than the total area of Earth's dry land. Mars is less dense than Earth, having about 15% of Earth's volume and 11% of Earth's mass, resulting in about 38% of Earth's surface gravity. The red-orange appearance of the Martian surface is caused by ferric oxide, or rust. It can look like butterscotch. Other common surface colors include golden, brown, tan, and greenish, depending on the minerals present. Martian soil is the fine regolith, a blanket of unconsolidated, loose, heterogeneous superficial deposits covering solid rock found on the surface of Mars. Its properties can differ significantly from those of terrestrial soil, including its toxicity due to the presence of perchlorates. The term Martian soil typically refers to the finer fraction of regolith. So far, no samples have been returned to Earth, the goal of a Mars sample return mission, but the soil has been studied remotely with the use of Mars rovers and Mars orbiters. This approach enables agreement across Martian remote sensing methods that span the electromagnetic spectrum from gamma to radio waves. Soil refers to all other, typically unconsolidated, material including those sufficiently fine-grained to be mobilized by wind. Soil consequently encompasses a variety of regolith components identified at landing sites. Typical examples include bed form, a feature that develops at the interface of fluid and a movable bed such as ripples and dunes, clasts, fragments of pre-existing minerals and rocks such as sediment deposits, concretions, drift, dust, rocky fragments, and sand. The functional definition reinforces a recently proposed generic definition of soil on terrestrial bodies, including asteroids and satellites, as an unconsolidated and chemically weathered superficial layer of fine-grained mineral or organic material exceeding centimeter scale thickness, with or without coarse elements and cemented portions. Similarly sized dust will settle from the thinner Martian atmosphere sooner than it would on Earth. For example, the dust suspended by the 2001 global dust storms on Mars only remained in the Martian atmosphere for 0.6 years, while the dust from Mount Pinatubo took about 2 years to settle. However, under current Martian conditions, the mass movements involved are generally much smaller than on Earth. Even the 2001 global dust storms on Mars moved only the equivalent of a very thin dust layer about 3 micron thick if deposited with uniform thickness between 58 degrees north and south of the equator. Dust deposition at the 2 rover sites has proceeded at a rate of about the thickness of a grain every 100 sols. Mars lost its magnetosphere 4 billion years ago, possibly because of numerous asteroid strikes, so the solar wind interacts directly with the Martian ionosphere, lowering the atmospheric density by stripping away atoms from the outer layer. Both Mars Global Surveyor and Mars Express have detected ionized atmospheric particles trailing off into space behind Mars, and this atmospheric loss is being studied by the MAVEN orbiter. Compared to Earth, the atmosphere of Mars is quite rarefied. Atmospheric pressure on the surface today ranges from a low of 30 Pascal on Olympus Mons to over 1,155 Pascal in Hellas Planitia, with a mean pressure at the surface level of 600 Pascal. The highest atmospheric density on Mars is equal to that found 35 km above Earth's surface. The resulting mean surface pressure is only 0.6% of that of Earth, 101.3 kPa. The scale height of the atmosphere is about 10.8 km, which is higher than Earth's 6 km, because the surface gravity of Mars is only about 38% of Earth's. The atmosphere of Mars consists of about 96% carbon dioxide, 1.93% argon, and 1.89% nitrogen, along with traces of oxygen and water. The atmosphere is quite dusty, containing particulates about 1.5 micron in diameter which give the Martian sky a tawny color when seen from the surface. It may take on a pink hue due to iron oxide particles suspended in it. The concentration of methane in the Martian atmosphere fluctuates from about 0.24 ppb during the northern winter to about 0.65 ppb during the summer. Estimates of its lifetime range from 0.6 to 4 years, so its presence indicates that an active source of the gas must be present. Methane could be produced by non-biological process such as serpentinization involving water, carbon dioxide, and the mineral olivine, which is known to be common on Mars or by Martian life. Almost all water on Mars today exists as ice, though it also exists in small quantities as vapor in the atmosphere. What was thought to be low-volume liquid brines in shallow Martian soil, also called recurrent slope linei, may be grains of flowing sand and dust slipping downhill to make dark streaks. The only place where water ice is visible at the surface is at the North Polar ice cap. Abundant water ice is also present beneath the permanent carbon dioxide ice cap at the Martian South Pole and in the shallow subsurface at more temperate conditions. More than 5 million km³ of ice have been detected at or near the surface of Mars, enough to cover the whole planet to a depth of 35 meters. Even more ice is likely to be locked away in the deep subsurface. Some liquid water may occur transiently on the Martian surface today, but limited to of dissolved moisture from the atmosphere and thin films, which are challenging environments for known life. On July 28, 2005, the European Space Agency announced the existence of a crater partially filled with frozen water. Some then interpreted the discovery as an ice lake. Images of the crater, taken by the high-resolution stereo camera on board the European Space Agency's Mars Express orbiter, clearly show a broad sheet of ice in the bottom of an unnamed crater located on vast Idas Borealis, a broad plain that covers much of Mars' far northern latitudes, at approximately 70.5 degrees north and 103 degrees east. The crater is 35 kilometers wide and about 2 kilometers deep. The height difference between the crater floor and the surface of the water ice is about 200 meters. ESA scientists have attributed most of this height difference to sand dunes beneath the water ice, which are partially visible. While scientists do not refer to the patch as a lake, the water ice patch is remarkable for its size and for being present throughout the year. Deposits of water ice and layers of frost have been found in many different locations on the planet. Valles Marineris, Latin for Mariner Valleys, named after the Mariner 9 million Argentine pesos orbiter of 1971-72 which discovered it, is a system of canyons that runs along the Martian surface east of the Tharsis region. At more than 4,000 kilometers long, 200 kilometers wide and up to 7 kilometers deep, Valles Marineris is one of the largest canyons of the Solar System, surpassed in length only by the rift valleys of the mid-ocean ridge system of Earth. Theories about the formation of Valles Marineris have changed over the years. Ideas in the 1970s were erosion by water or thermokarst activity, which is the melting of permafrost in glacial climes. The most agreed upon theory today is that Valles Marineris was formed by rift faults like the East African Rift, later enlarged by erosion and collapsing of the rift walls. It has also been proposed that Valles Marineris was formed by flowing lava. Landslides have left numerous deposits on the floor of Valles Marineris and contributed to widening it. Possible triggers of landslides are quakes caused by tectonic activity or impact events. Both types of events release seismic waves that accelerate the ground at and below the surface. Most sizable craters on Mars date to the late heavy bombardment, 4.1 to 3.8 billion years ago, the Noachian period, and are older than the landslide deposits in Valles Marineris. However, 3 craters, including the crater Edemans, have been identified, on the basis of their proximity and later dates, as ones whose formation may have caused some of the landslides. Olympus Mons is a large shield volcano on Mars. The volcano has a height of over 21.9 kilometers as measured by the Mars Orbiter Laser Altimeter. Olympus Mons is about 2.5 times Mount Everest's height above sea level. It is one of the largest volcanoes, the tallest planetary mountain, and approximately tied with Rhea Silvia as the tallest mountain currently discovered in the Solar System. It is associated with the Tharsis Montes, a large volcanic region on Mars. As a shield volcano, Olympus Mons resembles the shape of the large volcanoes making up the Hawaiian Islands. The edifice is about 600 kilometers wide. Because the mountain is so large, with complex structure at its edges, allocating a height to it is difficult. Olympus Mons stands 21 kilometers above the Mars global datum, and its local relief, from the foot of the cliffs which form its northwest margin to its peak, is over 21 kilometers, a little over twice the height of Mauna Kea as measured from its base on the ocean floor. The total elevation change from the plains of Amazonas Planitia, over 1,000 kilometers to the northwest, to the summit approaches 26 kilometers. The summit of the mountain has 6 nested calderas, collapsed craters, forming an irregular depression 60 kilometers times 80 kilometers across and up to 3.2 kilometers deep. The volcano's outer edge consists of an escarpment, or cliff, up to 8 kilometers tall, although obscured by lava flows in places, a feature unique among the shield volcanoes of Mars, which may have been created by enormous flank landslides. Olympus Mons covers an area of about 300,000 kilometers square. Cydonia is a region on the planet Mars that has attracted both scientific and popular interest. The name originally referred to the albedo feature that was visible from earthbound telescopes. The area borders the plains of Acidalia Planitia and the highlands of Arabia Terra. The region includes the named features Cydonia Mensi, an area of flat-topped mesa-like features, Cydonia Coles, a region of small hills or knobs, and Cydonia Labyrinthus, a complex of intersecting valleys. As with other albedo features on Mars, the name Cydonia was drawn from classical antiquity, in this case from Kydonia, a historic polis on the island of Crete. Cydonia contains the face on Mars, located about halfway between the craters Arundus and Bamberg. Cydonia was first imaged in detail by the Viking 1 and Viking 2 orbiters. In one of the images taken by Viking 1 on July 25, 1976, a 2-kilometer-long Cydonian mesa, situated at 40.75 north latitude and 9.46 west longitude, had the appearance of a humanoid face. When the image was originally acquired, Viking chief scientist Gary Soffen dismissed the face on Mars in image 035A72 as a trick of light and shadow. A second image, 070A13, also shows the face, and was acquired 35 Viking orbits later at a different sun angle from the 035A72 image. This latter discovery was made independently by Vincent DiPietro and Gregory Molinar, 2 computer engineers at NASA's Goddard Space Flight Center. DiPietro and Molinar discovered the 2 misfiled images, Viking frames 035A72 and 070A13, while searching through NASA archives. The resolution of these images was of about 50 meters/pixel. More than 20 years after the Viking 1 images were taken, a succession of spacecraft visited Mars and made new observations of the Cydonia region. These spacecraft have included NASA's Mars Global Surveyor, 1997-2006, and Mars Reconnaissance Orbiter, 2006, and the European Space Agency's Mars Express Probe, 2003. In contrast to the relatively low resolution of the Viking images of Cydonia, these new platforms afford much improved resolution. For instance, the Mars Express images are at a resolution of 14 meters/pixel or better. By combining data from the high-resolution stereo camera on the Mars Express probe and the Mars Orbiter camera on board NASA's Mars Global Surveyor, it has been possible to create a three-dimensional representation of the face on Mars. The Cydonia facial pareidolia inspired individuals and organizations interested in extraterrestrial intelligence and visitations to Earth, and the images were published in this context in 1977. Some commentators, most notably Richard C. Hoagland, believe the face on Mars to be evidence of a long-lost Martian civilization along with other features they believe are present, such as apparent pyramids, which they argue are part of a ruined city. Phobos is the innermost and larger of the 2 natural satellites of Mars, the other being Deimos. The 2 moons were discovered in 1877 by American astronomer Asaph Hall. It is named after Phobos, the Greek god of fear and panic, who is the son of Ares, Mars, and twin brother of Deimos. Phobos is a small, irregularly shaped object with a mean radius of 11 km. Phobos orbits 6,000 km from the Martian surface, closer to its primary body than any other known planetary moon. It is so close that it orbits Mars much faster than Mars rotates, and completes an orbit in just 7 hours and 39 minutes. As a result, from the surface of Mars it appears to rise in the west, move across the sky in 4 hours and 15 minutes or less, and set in the east, twice each Martian day. Phobos is one of the least reflective bodies in the Solar System, with an albedo of just 0.071. Surface temperatures range from about 4 Celsius on the sunlit side to 112 Celsius on the shadowed side. The defining surface feature is the large impact crater, Stickney, which takes up a substantial proportion of the Moon's surface. The surface is also home to many grooves, with there being numerous theories as to how these grooves were formed. Images and models indicate that Phobos may be a rubble pile held together by a thin crust that is being torn apart by tidal interactions. Phobos gets closer to Mars by about 2 cm per year, and it is predicted that within 30 to 50 million years it will either collide with the planet or break up into a planetary ring. A person who weighs 68 kg force on Earth would weigh about 40 g force standing on the surface of Phobos. Deimos is the smaller and outermost of the two natural satellites of Mars, the other being Phobos. Of similar composition to C and D-type asteroids, Deimos has a mean radius of 6.2 km and takes 30.3 hours to orbit Mars. Deimos is 23,460 km from Mars, much farther than Mars's other moon, Phobos. It is named after Deimos, the ancient Greek god and personification of dread and terror.